this is arithmetic progressions. Firstly, what are they, right? So a linear sequence like this. What do I mean by a linear sequence? Where to go from one term to the next, we need to add a constant. So this constant right here is going to be plus 3, as we see here. That constant that we are adding to each term to get to the next is called our common difference. Now that common difference could also be negative if our terms are reducing as we go forward, but in this case it's positive 3. And so this whole thing is known as an arithmetic progression, and this thing right here is known as the common difference. Now the more general term, remember this is an example, the more general, we use a as our first term, okay? Then we add d to it, d we call it the common difference, to get our second term, which is a plus d. And then we add d to that to get our third term, which is a plus 2d, and so on. Remember, this is our first term. That means it's in position 1. And the way we identify that what position it's in, we give it a value for the variable n. So n equals 1, n equals 2, n equals 3, and so on. N equals 4, and n equals 5. Then we want to get a general nth term. So for example, suppose we have a term n. How will we get the term n? We will use this thing right here. So a plus n minus 1 times the common difference, which is what this is here. N is 5 in this case. We have a plus n minus 1, which is 5 minus 1, which is 4, times d. And that's how you get your nth term. Remember, the term is the value while n is the position. An example, find the number of terms in this arithmetic progression. So remember, the number of terms is the value of n that you have for the last term. The reason for that being, if your n is 15 for the last one, then remember you started from n equals 1, therefore you're going to have 15 terms in your progression. And so here what we want to do first is find your d, and your d here from negative 3 to 1 is positive 4, and from 1 to 5 is again positive 4, and so on. So all of them are positive 4. That just tells you your d is positive 4. Your a in this case is negative 3. Now you want to find your n for your this nth term. So we're going to use our formula for nth term. Nth term equals a plus n minus 1 times d. Your nth term is going to be 237. Your a, as we know, is negative 3. Then we're going to add plus n minus 1, we don't know our n value, times d, which is positive 4. This will give us 240 after taking negative 3 to the other side, equals 4n minus 4. Take this again to that side, we get 244 equals to 4n. After dividing by 4 on both sides, we get that n equals to 81. That means we have a total of 81 terms, and this 231 was the 81st term. Okay? Next, the fourth term of an arithmetic progression is 7. That means when n equals 4, your nth term equals 7. And the 10th term is 16. That means when n equals 10, your nth term equals 16. Find the first term and the common difference. So we want to find our a and we want to find our d. And with that, we can just write down the formulas for both, right? So nth term, which is 7, equals to a, which we don't know, plus n minus 1. So 4 minus 1, which is 3, times d. Then the second one, nth term, which is 16, equals to a plus n minus 1, so 10 minus 1, which is 9, times d. And this is a perfect case of a simultaneous equation. We can solve this by elimination or substitution. Let's just use elimination in this case because it's possible. We'll subtract here, we'll get negative 9 equals, the a's cancel out, and then 3 minus 9 is negative 6d. Over negative 6 over negative 6, we get that d is 1.5. Now that we found d, we can find our a as well. So 7 equals to a plus 3 times 1.5. 7 equals to a plus 4.5. Minus 4.5 on both sides, we get that a equals 2.5. Which is going to give us our first term, which is 2.5. And our common difference, which is 1.5. Next, the nth term of an arithmetic progression is 5 minus 6n. So nth term, which is equal to a plus n minus 1d. That is equal to 5 minus 6n. Find the first term and the common difference. So here you need to compare these two. You need to compare the general and you need to compare what you're given. So this right here will just become a plus dn minus d. And we need to compare it to 5 minus 6n. So obviously this is the only term with n in the general formula. And this is the only term with n in the formula we're given. And therefore we can compare them. dn equals to negative 6n. Therefore d equals negative 6. Then we know that the two constant terms without a variable are going to equal to each other. Therefore a minus d equals to 5. But we know the value of d, which is negative 6. So a minus negative 6 equals 5, which means a plus 6 equals 5, which means a equals negative 1. And so our first term is going to be negative 1, while our difference is going to be negative 6. Next, when we are talking about the sum of an arithmetic series, suppose this series right here, right? 1 plus 2 plus 3 up to 100. And this question was asked to this guy right here, okay, if you're interested. And this was asked to him when he was quite young. And he figured out this method, which is used up to now, and we use it in our Cambridge syllabus, to solve for the sum of an arithmetic series. So what he did, he reversed this sum and started with 100 plus 99 plus 98. Then he added it to the original sum, which is 1 plus 2 plus 3, and he got this right here. Yes? Each term was equal to 101. 101, 101, 101. And this repeated how many times? It repeated 100 times, right? Because there were 100 terms in it. The n was 100. So what they did at the end was that n, that 100, multiplied by the addition we got, which is 101, which was, by the way, the first term plus the last term, and then they divided it by 2, because this is the sum for 2 of those arithmetic series. So if you wanted 1, then you divide it by 2 at the end, and that's how we found the sum of that series from 1 to 100. And we use that for any series from then on. So the general formula we got then was that for the sum of the first n terms, what we would do is take n, which is 100 in this case, n, multiplied by the first plus the last term, which is 101, and then divide that whole by 2. Remember, you can find the value of the last term if you don't have it. How will we find that? By doing the normal nth term formula. So a plus n minus 1d, where n is the last position, d is obviously the common difference, and a is the first term. And we end up with a general formula of this sort. Sum of the first n terms equals to n over 2 multiplied by 2a, the a from the last term and the original a, plus n minus 1 d. And this would give you the sum of the first n terms. Another formula we don't use that often, but it's just good to know intuitively, is that the nth term is equal to the sum of the first n terms minus the sum of the first n minus 1 terms. Meaning what? If we want to get the nth term, so the 100th term for example, then we will take 1 plus 2 plus 3 plus 4 up to 100 minus 1 plus 2 plus 3 plus 4 up to 99. And what this will leave us is only the last term that is missing. So that's how you get the nth term from two sums. Next, in an arithmetic progression, the first term is negative 12. So a equals negative 12. The 17th term is 12. Therefore, the nth term, which is 12, equals to a, which is negative 12, plus n minus 1, 17 minus 1, which is 16, times d. And then we have that the last term is 45. Therefore, L equals 45. Find the sum of all the terms in the progression. So to find the sum of all the terms, we will need the total number of terms, which you don't have. We will need the a, which is negative 12 here. We have it. And we will need the last term, which is 45. And we have that. But to find the n that gives us that last term, we will need to use the nth term formula. So 45 being the nth term equals to a, which is negative 12, plus n minus 1 times d, which you don't have. So we don't have n, we don't have d. So if we get d, then we will be able to find the n that gives us that last term. How will we find the d? Using the 17th term formula, because we have only one variable here. So we get 24 equals to 16d. D will be 1.5. So we end up getting 45 equals to negative 12 plus n minus 1 times 1.5. We'll take this to the other side. We end up getting 57 equals to 1.5 times n minus 1. Divide by 1.5, divide by 1.5. We end up getting 38 equals to n minus 1. Add 1 to both sides, we get n equals 39. And now we have our n, which is 39. We have our a, which is negative 12. We have our l, which is 45. And we can use our formula for the sum. So Sn is equal to n over 2, so 39 over 2, times a, which is negative 12, plus l, which is 45. And this will give us 643.5. That's going to be the sum of all the terms in that progression. Next, the 10th term in an arithmetic progression is 14. That means the nth term is 14 equals to a plus n, which is 10, minus 1, which is 9, d. And the sum of the first 7 terms, so S7, which is equal to 7 over 2 times a plus l, is equal to 42. Find the first term of the progression and the common difference. So here we have one equation. If we get another equation with a and d, we can find our a and d by using simultaneous equations. And remember that we have another way of representing this, where we change the l into the nth term formula. So we end up getting S7 equals to 7 over 2 a plus n minus 1. The n is 7 right here, because that's the last term. 7 minus 1, which is 6d, which is also equal to 42. So we end up getting 7 over 2 times 2a plus 6d, and that's equal to 42. We can divide this by 2 times 7, which will make it 7a plus 21d equals 42. And our original one was a plus 9d equals 14. Let's solve this by substitution. From this one below, we have a equals to 14 minus 9d. And we can put this into the first equation right here. So we'll end up getting 7, 14 minus 9d plus 21d equals 42. Here we get 98 minus 63d plus 21d equals 42. And after taking 98 to the other side, we get negative 63d plus 21d, which is negative 42d. That will equal to 42 minus 98, which is negative 56. Then we can divide by negative 42. Divide by negative 42. We get that d is equal to 4 over 3. Then from that, we can find the value of a, because a plus 9 times 4 over 3 equals to 14, which will give us that a is equal to 2. And so we get our first term a equals 2, and the common difference d equals 4 over 3. Next, the sum of the first n terms of a particular arithmetic progression is given by this thing right here, 4n squared plus n. So Sn, which is usually n over 2 times 2a plus n minus 1d, and this is given by 4n squared plus 4n. We can rewrite this, n over 2, 2a plus dn minus d equals to 4n squared plus 4n. We can multiply in. We get an plus dn squared over 2 minus dn over 2. And we can compare this to the original one, 4n squared plus n. We can know that this 4n squared can only be represented by this d over 2n squared. Therefore, dn squared over 2 equals to 4n squared, and thus d over 2 equals to 4. Multiply by 2 on both sides, we get that d is equal to 8. Then we can use the other equivalence, where an minus dn over 2 will equal to n. And that means a minus d over 2 equals to 1, using the coefficients. We know that d is equal to 8, and so a minus 4 will equal to 1, which gives us that a equals to 5. So we have a equals 5 and d equals to 8 from the arithmetic progression formula that they gave us. Then we can find the expression of the nth term, where nth term equals to a plus n minus 1 times d. We have a value of a and d, so this is going to equal to 5 plus n minus 1 times 8. And that's going to be our nth term expression.